We're going to start with our 7th webinar of the day with Dr. Robert Beach. Dr. Beach is a senior economist, fellow, and director of the Agricultural Resource and Energy Economics and Policy at RTI International. He specializes in the development and application of economic models designed to analyze agricultural, environmental, energy, transportation, and natural resource regulations, programs, and policies with a focus on climate change impacts and adaptation, greenhouse gas mitigation, and bioenergy. Today, he'll be talking about the economics of climate change, mitigation, and adaptation. So thank you for your time, Dr. Beach, and go ahead.
All right, thank you, Dan. I seem to have come down with a cold yesterday, so apologize in advance for my voice or any coughing. As Dan said, I'm at RTI International, which is a not-for-profit independent research organization that was founded by the 3 universities in the Research Triangle Park region of North Carolina, North Carolina State University, UNC Chapel Hill, and Duke University. And I'm going to talk a little bit today about some of the considerations at a broader scale for potential market implications and as well as interactions with alternative policies that may relate to climate change adaptation and mitigation. Okay, so some of the kinds of work that I have in mind in terms of economic assessments related to climate are around climate change impacts and adaptation, where there are a number at the state, regional, U.S. and global level, looking at changes potentially in agricultural and forest productivity and the implications for commodity markets and net emissions from the sector. Another consideration is potential effects on risk management strategies and crop insurance, as well as some assessment of what are the benefits of reducing climate change in terms of implications for agricultural productivity and forest productivity. Another set of assessments focus more on the greenhouse mitigation potential that can be provided by the agriculture and forestry sectors, as well as potential market participation by landowners. And on a related topic, bioenergy is one category of mitigation that's gotten a lot of attention in the U.S. and in the Southeast. There's a lot of interest around forest biomass to bioenergy, as well as other agricultural feedstocks potentially. But then there's some important questions around assessing what the net market and environmental impacts may be when you have large-scale bioenergy expansion. And then another set of economic assessments relate to land use and what are the implications of different future scenarios for population growth and climate, and where that growth may be spatially distributed, and what kind of impacts does that have on land use and commodity markets. Oops, sorry, I jumped to. Again, certainly weather clearly has a very important impact on agricultural production. And so even under constant climate, weather is constantly changing and we hit different extremes, and they have large implications potentially for yields in a given year. And then what we're talking about here on top of that is changes potentially in what the typical weather is, or average changes in the averages, away from long-term averages to potentially new averages outside of what we experienced historically. And certainly there are clearly what historical climate has been affects the spatial distribution of where people live, animals, plants, ecosystems, and affects what crops are grown in what locations. And so potential changes in that affect both productivity and what may be most suitable in a given location. Just briefly, a couple of examples from the National Climate Assessment for the U.S. There's some expectations that in the absence of mitigation, that there be very substantial increases in temperatures at the global level, and depending on the level of mitigation that's achieved, with this RCP 2.6 scenario being, relatively large mitigation actions, and then, going up with higher concentrations to potentially greater temperature changes. There's also some potential for increased concentration of precipitation and fewer, heavier precipitation events, which may actually contribute to an increase in both flooding and drought. If you have large amounts of precipitation in a given event, it may then lead to more runoff and flood, but it may also you may also experience more drought between events, given that there are fewer, heavier events. And so some of the anticipated impacts include increased frequency and intensity of heat waves, shifting regional precipitation patterns, as well as precipitation potentially being concentrated in fewer heavy precipitation events, sea level rise, threats to other ecosystems, shifting habitats, also impacts on the oceans, and for this talk, changes potentially in agricultural and forest yields, where there are direct impacts on growth rates and yields, and they vary in a complex way depending on how precipitation changes and how temperature changes and what baseline conditions look like. In addition to direct effects on crop productivity, and there's also heat stress impacts on livestock. There's also expected to be increased pests and greater variability in yields. And so an implication of that people looked at the global level is potential implications for food security and provision of sufficient safe and nutritious food, given changes potentially in crop and livestock productivity, which may affect what outputs are grown where. And it also means that the implications for the Southeast don't depend only on what happens in the Southeast, but they depend on what happens in the rest of the U.S. and even globally, because so many of the commodities are traded at a global level. And so depending on what the relative changes in productivity are, will have a large influence on markets and on how production patterns may shift and what changes in crop mix and availability and market prices you may see. If your yields decline some, but everyone else's decline more, you may be in a relatively better position. There's also potential impacts on just nutritional content and other implications. So there's related to that, then there's interest around mitigation efforts, but it's very important to consider mitigation efforts in the agricultural sector can have large impacts on agricultural markets and potentially on food prices, which also have effects for food security. So this is an example from a study we worked on with USDA looking at the potential impacts on crop insurance. And so this is for one particular climate model. There are many different climate models, and on the next couple slides, I'll just quickly show a little bit of variability across different models, give you some sense of what that looks like. But there's quite a lot of spatial variation in what we may expect. So from left to right, on the top three panels, it's showing the change in spring average minimum temperatures, spring average maximum temperatures, and spring precipitation for mid-century compared to a baseline of a historical baseline. And then summer temperatures in the three panels below, again, minimum, maximum, and changes in precipitation, where there's some variability. In this particular model, the Southeast tends to see a little bit less warming than a lot of the rest of the United States, and sees some moderate drying in the spring, but a wetter summer, for instance. Now, in the next slide is just showing a different model, which, again, there's a heterogeneous pattern across the United States. The pattern differs a little bit across models. There are a lot of reasons for, some variability across different climate models, that they implement the same emissions patterns, but because they treat atmospheric conditions or model atmospheric conditions a little bit differently, they see a little bit different patterns. But somewhat similarly, again in this model, a little bit less warming potentially in the south than many other areas, and potentially increased rainfall in the summer. This is just another example showing a pattern for another one of the climate models, and finally for a fourth that is has a relatively wetter outlook in much of the southeast in the spring, and again in a more concentrated part of the southeast in the summer. Now, so one implication of that is, so across these four climate models, for the top four panels and the bottom four, you have some implications for what yields may look like, with some variability spatially. And again, in terms of regional comparative advantage in a given crop, this is an example for corn. It depends what happens not only in your own region, in the south, in your own region, but also, again, elsewhere in the United States and even in the world. Next slide shows a similar picture for non-irrigated and irrigated soybean yields. A little bit different pattern again. This model on the right that has relatively more precipitation also has relatively positive yield impacts. It depends quite a bit on how precipitation patterns change, in addition to the temperature implications. And finally for wheat, which shows a little bit different pattern, it tends to have increasing yields in the south and decreases in the more northern regions. And so one of the implications for yields is that you may experience changes not only in the mean, but also in the variability of the yields you may experience. And the other thing that's that's really interesting and makes it complicated is that depending on what happens to precipitation and temperature, it's possible that you may actually see increases in the mean yields compared to the baseline, or decreases. And in cases where you were rain limited and you actually saw increases of precipitation, you may actually see higher yields and less variability, whereas in other regions you may experience just the opposite. And so one thing, a common finding across many of the studies is that you're likely to see more variability. That's important to plan for more variability in yield outcomes, but there's still some uncertainty around what the direction of those impacts may be. And so for, as part of this this study looking at potential impacts on the climate insurance program, on the crop insurance program, we are looking at, given the yield changes from those four different climate models, what kind of changes in market prices might you experience? And so there's considerable variation with potentially fairly sizable increases or decreases compared to the baseline, and it really depends on on the economics of production and how the yields and relative returns to different crops change. It may be that the yields for a given crop go down in your region, for instance, but again, if they go down even more elsewhere and prices rise, you may expect to see a response of shifting more area into that crop, even though the yields are lower. So really, as depending on interactions between what landowners are doing in response to the market signals they're facing, and of course their interactions that affect what the market outcome is based on what landowners choose to do with their land. And so and then following up on that, in one recent study that we were involved in, looking at, so if you reduce the amount of climate change, or if it happened, I mean, this is really assuming, if you just had less climate change outside of a policy where agriculture was specifically being asked to take actions to mitigate, but greenhouse gas concentrations fell, it was looking at what might happen under two different climate models to yields with reduced changes in climate versus a case without mitigation and higher rates of change. And in general, the South tended to be a region across some of the major crops that experienced some of the largest increases in yields. And, at least in that particular assessment, part of that is that, with a general warming trends, you would see some benefits from more northern regions, and as a result, there was some shifting northward of some crops, and then mitigating some of that change. Reducing some of the change brought some bigger gains in yield in some of the more southern regions. And and another important consideration is that not only are there potentially changes in crop yields compared to what they would have been in the baseline, and where there's been a lot more work, there are also effects on livestock and forest productivity. Again, so livestock, there's potentially effects from direct heat stress. There's also changes in pasture productivity. And in a lot of assessments, pasture grasslands do relatively better than crops under a future warmer climate. And so changes in crop yields and crop mix affect feed markets and livestock production costs. May also have changes in disease incidence. Forest as well will be, the growth rates are impacted by changes in precipitation and temperature. A lot of the projections actually have forest growth rates rising over the next few decades under climate change. Trees growing faster due to higher carbon dioxide concentrations and warmer temperatures. And in many of the areas where commercial forests are concentrated, there's often increases in precipitation anticipated. But then by the time you get later in the century, there's the trend tends to become a little more negative. But another thing that's really important to consider for forests is pest pressure and wildfires, which are expected to increase and may have a substantial impact on what the net impacts on forests are. And so again, an important aspect from an economic standpoint is that all of these different changes are interacting at once. I mean, depending on what happens to the yields that you anticipate and the variability of the yields for different uses for land, you would anticipate, that landowners will respond to those mean and the mean and distribution of returns that they would anticipate, whether they have their land in crops or livestock on pasture or forest, and which crop it is and which production practice, and would result in an overall change in the distribution of what's being grown and where. And again, from this recent study, with global reductions in climate change, there tends to be an increase in crop yields, and as a result, there's some downward pressure on prices. And so it's good news for consumers in that yields are higher and prices are lower. the impacts on producers are a little more mixed because prices are lower. So it depends how much do your individual yields increase compared with this overall price effect due to an overall rising average yield. So there are many different adjustments that can be made to prepare for and adjust to a changing climate. Like enhance early warning systems better, climate services type information where you have short-term climate variability information further in advance to make decisions about crop mix and planting and other management decisions, as well as on the veterinary side and animal husbandry, as well as there's a lot of research that's looking at new crop varieties that may be heat or drought tolerant or salinity tolerant if you have more saltwater intrusion, or other modifications that may help to mitigate any reductions in yield, as well as changes in production practices and what crops are grown where as a way to adapt to these potential changes in the yields that may be experienced. And again, I mean, one important issue for USDA and for the U.S. government is thinking about how much you help in risk management around this. And so from a crop management standpoint, I mean, that's one way you can help to mitigate risk. And in terms of the insurance program and what the losses may be and setting insurance rates, in addition to changes in mean yields, it's really changes in variability that are very important. And again, for decisions around what farmers would plant and what insurance they may have, but it affects the probability of losses. From an insurance standpoint, you really care about what's the probability of those very low yield, poor outcomes, the lower tail of a crop yield distribution. And again, in general, while there's some uncertainty and a lot of heterogeneity and complexity around how yields may change over time and by crop and region, generally there's an expectation you'd have increased variability, which would tend to increase the chances that you would have one of those really low yield outcomes. There's also been a big shift towards revenue-based insurance in recent years in the U.S. And in that case, your losses will depend on what happens to prices as well. It starts to depend what happens everywhere else in addition to what happens on your own farm, because that influences the price that's being received. And if others also have low yields, then prices will rise, and that will partly offset a yield reduction and may reduce the potential for insurance payouts. Another issue is just thinking about whether it's feasible for the program to continue covering certain crops, regions, coverage levels, if you have sizable changes in climate, in typical climate and variability. It's also important to consider that it doesn't really reduce the risk or help farmers to adapt practices necessarily, but it transfers risk and helps to mitigate against, for an individual having a very poor yield, poor crop. And of course, there are a large number of potential mitigation options that can be undertaken. And one of the models that we use for a lot of our agriculture and forestry analysis in the U.S., the FASA model, Forest and Agriculture Sector Optimization Model, there are a number of options around forestry, moving land into forest, changing management to encourage faster growth and faster carbon sequestration. There's also a number of options around how you manage livestock and crops and what's grown, and as well as a major one in recent years has been production of crops for use as bioenergy feedstocks. And so as one example, looking at, as you provide higher carbon prices, so higher incentives to landowners, there is, and with prices rising over time, this is showing by decade out to 2060, there's generally some increase. Well, one, a lot of the mitigation potential that has been found in a lot of the work is from forestry, and it's simply because trees sequester so much carbon that there's very, very large potential for storing carbon in trees when there are incentives to increase the level of the area of forest as well as the amount of carbon being stored per acre. And in addition to the large amounts coming from changes in forest management, often to intensify or otherwise increase carbon per acre, and the blue areas shows increased afforestation, where you have land moving from other uses into forestry. We also see a large increase potentially in bioenergy as you move further out into over time, and some of the carbon prices that are rising at 5% per year, like in these last two cases, become relatively higher and give larger incentives for shifting into bioenergy production. Now, what does that mean for land use? That particular example, that scenario, at a price of $15 per ton, whether a constant at $15 per ton, or where it's rising over time, it tends to increase the amount of land in timberland, and take land out of cropland and pasture, with some movement back into cropland, and largely devoted to energy crops like switchgrass and miscanthus as you get further in time, and there's that bioenergy growth. With higher incentives, generally we're seeing an even larger shift towards forestry and out of agriculture, just due to the large payments per acre associated with that much land, and with the amount of carbon stored on an acre of forest. One implication for that is an expected reduction in crop production. This is one example looking at the global level in cases where there's a value placed on a policy that places a value on carbon being stored, and as a result you end up with reductions in crop production and some fairly sizable reductions, potentially due to largely to shifts towards forest as a result of the incentives for storing carbon in forest. So again, some implications for food security potentially. And then, again, another type of mitigation that may have an influence on agriculture and forestry outcomes is encouragement of bioenergy. So this is looking at biofuels. This particular example, this is some work from the revised renewable fuel standard from a couple of years ago, where requiring increases in biofuels results in a pretty sizable projected shift in the amount of and the distribution of how corn would be used, with a large increase for ethanol and some shifting away from feed and from exports and from all other uses. And similarly for soybeans, away from towards biodiesel and away from other uses as well. And so, again, implications for that is, in general, there's projected reductions in a lot of other commodities, and in general increases in commodity prices as a result of that increasing demand for land resources to produce bioenergy, in addition to the food and feed and fiber that's being produced on the land. Similarly, in studies looking at bioelectricity potential, there's a potentially a large potential for using forest biomass to generate electricity, but given constraints on the amount of biomass available, a more flexible. So on the left, it's assuming that you're only using forestry sources, but you can substitute short rotation woody crops for traditional forestry products, and that there's more substitutability in what land can be used for. On the right, if you restrict the ability to substitute, then you actually don't get as much. Well, you don't only not get a reduction, you may even increase greenhouse gas emissions, and you also have larger effects on prices. So one of the important considerations is allowing more flexibility potentially in where biomass sources can come from, in terms of both the potential price effects as well as the environmental benefits. Also, just looking briefly at, in terms of biomass supply, the Southeast and the South in general, the South Central and Southeast regions have a large potential supply of logging residues, and so that to the extent that we see an expansion of bioelectricity, there's a relatively large potential for logging residues to bioelectricity in the Southeast and South Central regions compared to other regions of the U.S. It influences overall returns to different, to alternative land uses, and has some implications for what form of biomass may be used to generate bioenergy and for the mitigation achieved. So overall, going through relatively quickly in a few different topics, climate change interacts with agriculture and forest land use and production decisions in a number of very complex ways. And so it's important to understand how climate change impacts potential changes in mean outcomes and variability, as well as policy designed to encourage adaptation and mitigation may interact and influence landowner decisions, and may influence what's the most attractive way in which to manage a given piece of land. And again, that's one of the key things that the economics and policy analyses are coming at, is trying to really think about and try to model and understand how these different changes may interact, and how land management may be influenced by markets, as well as how markets are influenced by land management. Land use competition, again, is very important. You would anticipate, given relative changes in productivity for different crops and for different uses of land, and policy incentives that may differ, you would anticipate changes in the relative distribution of land across different uses. And again, there's adaptive strategies that may reduce climate impacts. They tend to reduce commodity prices and provide benefits to consumers. Mitigation policy can help reduce impacts as well, but there are certainly some complex trade-offs potentially with food prices. If landowners are being paid or provided incentives with undertaking certain practices, they may potentially benefit as well. They may face higher energy prices, but through sequestering carbon or other changes in practices, it may potentially provide a new income stream. Also overall, there is a fairly large mitigation potential from the sector, from changes in agricultural practices, forestry practices, and bioenergy production. But again, there are a lot of important interactions between climate change impacts, the actions that may be taken to adapt to increase climate variability and improve resilience, and potential mitigation. And so with that, I will, that's the end of my presentation, and I will would be happy to take any questions.